So to start us off, I actually have Richard here. And Richard, you're going to walk us through sort of like the thinking and the process and the methodology behind selecting apps, right?
That's right, yeah. I'm going to talk a bit about the process that you might go through to select an application that might be a good candidate for migration. And I'll actually do a demo of moving a very simple ASP.NET SQL Server app to the cloud.
Nice. All right, so with that, I'll let you get started. And remember, this is live at Interactive, so make sure if you have questions for us, please type them into the chat. We'll make sure we answer them either on the chat themselves or in the Q&A session at the end of the day. With that, Richard, they're all yours.
Great. Thanks very much, Jonathan. Okay. So what I'm going to be talking about today is migrating to Windows Azure. So the agenda for today's presentation is we're going to start off by talking about the process by which you can actually select applications that would be good candidates for moving to Windows Azure. And after that, we're going to talk about some architecture things. What components are there in Windows Azure, and what can you use them for, especially in relation to the existing applications that you have today. Next, I'll do a demonstration of actually migrating an application to the cloud. And finally, we'll end off by looking at some of the challenges and things you may want to think about when you're looking at moving applications to the cloud. So first off, we'll take a look at the process. So there's four main stages in a process that you can use to figure out what applications might be good candidates for moving to the cloud. In the first stage, the prepare phase, what you want to do is you want to get familiar with sort of different cloud computing concepts and what's in Windows Azure as well. Next, you want to take a look at sort of what's the business and technical landscape within your company. So for instance, what objectives and constraints are you working under? After you've done that, you'll move to the identify stage, and what you're going to do there is you're going to create an inventory of the applications within your company, and for each one of those you're going to take a look at the business and technical characteristics of each application and how well those applications align to the objectives and constraints that you identified in the prepare phase. After that, you're going to filter those applications down and come up with a short list of candidates that you want to do a bit more detailed assessment on, and that moves us into the assessment stage. So what you're going to do there is for each application on your short list, you're going to take a look at the business and technical issues you've got. You're going to do a high-level architecture mapping, maybe do a total cost of ownership study to make sure it's affordable, and then you're going to come up with your final list of candidates to migrate. And then after that, you're going to move into the plan and execute stage, where what you're going to do there is you're actually going to come up with a project plan for each of your applications and come up with a more detailed architecture and actually execute the migration. So we're going to be talking about each of these four stages in a bit more detail on the subsequent slides. So first off is the prepare phase. So what you want to do, the first thing you want to do is get more educated about Windows Azure and cloud computing in general. Now a really good way of doing that is to go to the windowsazure.com site and download the Windows Azure SDK. This will help you sort of package up your applications so that they can be deployed to Windows Azure. As well, there's the Windows Azure Platform Training Kit. This is a really good collection of files that will help you learn more about Windows Azure. There's a lot of PowerPoint presentations and training in there. There's a lot of hands-on labs that cover pretty much every aspect of the Windows Azure platform. So it's a really good way of sort of getting your hands dirty and learning what's there in Windows Azure. So once you've done all that, the next thing you want to do is take a look at the business constraints that are in your company. So these could be things like budget restraints, resource constraints, sorry. You may have certain business cycles that you have to deal with on a sort of a monthly, a quarterly, or a yearly basis. You may have legal or regulatory hurdles that you need to overcome in your organization. And you may need to look at what projects are in the pipeline right now or are coming down in the future and take those into consideration. After you've done that, you also want to figure out what the objectives of your company are as well. So you want to do things like maybe are you trying to reduce costs? Are you trying to better utilize the resources you have in your company? Are you trying to improve things like customer service or service delivery by being able to provision service faster? Or maybe you just want to integrate better with the partners you have, be they internal or external. You also want to know what your IT strategy is. So things like what are your preferred technology? Does your company prefer to use .NET or Java or other technologies as well? What kind of architecture principles does your company adhere to? Maybe you want to go with more of an SOA type architecture. And finally, what integration points you have in your company. Maybe you've got data marts you need to integrate to, or your ERP systems and things like that. So collectively, all these things are going to help you figure out what the risks are with migrating applications, what some of the critical success factors might be that will help you judge the success of your migrations, as well as being able to characterize what the business value is going to be in migrating an application to the cloud. So next we have the identify stage. So what you're going to do here, now that you've collected all this information and you've got all this education, is you want to inventory the applications within your company and figure out which ones would be good candidates for moving to the cloud. So for each application, what you're going to do is you're going to find out what the core business and technical attributes of each application are. So in terms of business attributes, what you want to look at is things like what's the business value of this application? Is it a mission critical application, or maybe it's only used by a single department? You also want to look at what's the business function of the application. Does it do HR? Does it do payroll or finance? Or maybe it integrates with equipment on your shop floor. You're also going to want to look at the technical attributes of each application. So these could be things like what components does it have? Does it have websites? Does it have web services? Does it have databases? Does it write to files? And things like that. You're also going to want to know what technologies it uses. Does it use .NET or Java or a variety of third-party components and things like that? And what does it integrate with? Does it need Active Directory? Does it integrate with your SAP system? All sorts of things like that. Once you've got all that, now you want to figure out sort of for each application is how well does it align to the objectives and constraints that we identified in the prepare phase. So an example here might be you may have a system where you've got a legal requirement that data can't leave Canada, but on the other hand that system may lend itself well to the cloud because you need to be able to scale it up to meet customer demand fairly rapidly. So for instance a marketing site and things like that. So once you have all this information, then you can start filtering down your inventory of applications to a short list for further consideration. In the next couple of slides, we're going to show a couple of ways that you could potentially do this filtering exercise. So first off, we've got a little matrix here. On the x-axis, we've got technical complexity from simple to complex, and on the y-axis, we have business value from low to high. And what we've done is, we've assess these two different attributes or things for each application, and the intersection of those two values, we basically allowed us to drop each application onto this matrix or quadrant. And that allows us to sort of subdivide our inventory of applications and help us figure out which ones we should focus on first. So for instance, so for instance, what you might want to focus in first on is the upper left-hand quadrant where you've got simple applications but that have high value to the business. These applications are going to give you a really good return on investment and may convince your executives to fund further migration exercises. Next, you may want to look at sort of simple low-value applications. These would be, generally speaking, very quick to migrate, and they're not going to have a lot of disruption or effect on the rest of your organization, so they'll be really easy to do. In the longer term, what you might want to look at is more complex high-value systems, because obviously there's going to be a lot of incentive to move those to the cloud. But you're probably going to want to avoid sort of the lower right-hand quadrant, those complex low-value systems, because the amount of effort you're going to have to put into the migration is probably not going to be worth the return on investment in the long run. Alternatively, another way you can look at coming up with this short list of applications is to come up with some sort of scoring scheme. So here, once again, we're looking at business value and technical complexity, but we've come up with a score. So on the business value side, we might have a 1 representing a very simple, very low value system, and a 10 being something that's mission critical. And on the technical complexity scale, we may have a 1 represent something that's very complex, and a 10 represents something that's simple. So what we can do then is we can score each individual system, add the values together, and come up with a total overall score. And then from there we might say, well, anything from a 0 to 10 is something that we don't want to consider. Anything from an 11 to a 15 might be a possible candidate for migration, and anything from a 16 to a 20 is something we definitely want to give serious consideration to. So the actual value, things that you might consider, here we're using value and complexity, you can use sort of any series of criteria that means the most to your company. So once we've got this sort of short list of applications, we can then move on to the assessment stage. So what we want to do here is for each application on our inventory, on our short list, we want to do a more technical, detailed assessment of the business and technical issues we face. So for instance, I mentioned you may have a business issue in the sense that you can't move data outside of Canada. So you may, at that point, disqualify the app from consideration for migration, or you might want to look at, well, maybe rather than doing an all-in approach where I try to move all the application components to the cloud, I look at doing a hybrid approach where I keep some components on-premise and move the rest into Windows Azure. That's more of a hybrid approach, and I'll be talking about that as we go. So for instance, in that case, we'd leave the database with all the sensitive data on-prem in a Canadian data center that my company has, and then I might move the presentation layer or the websites into Windows Azure. Another thing you might want to consider when you're looking at sort of which components can move and which ones can stay is whether you do what we call a lift and shift or a lift and refit. With a lift and shift, you're basically trying to take the application as much as possible as is with doing very little modification and moving it into the cloud. And a lot of the infrastructure as a service components that Microsoft has introduced this year in Windows Azure really helps facilitate that. Alternatively, you can look at doing a lift and refit where you're basically modifying your applications, tying in aspects of the Windows Azure SDK to take advantage of a lot of the functionality that's in Windows Azure for things like scalability and high availability. Once you sort of looked at all these issues, another thing you're going to want to do is look at the total cost of ownership for each application. Generally speaking, running things out of the cloud can be less expensive, especially if you're looking at, it's more of an operating expense as opposed to capital expenditure that you would have to do for buying on-premise hardware. With Windows Azure and other cloud providers, your resources are really based on, your costing is really based on how many resources you consume. So if your application is very inefficient in terms of how it sends data, maybe it's not compressing it, maybe it's very chatty in terms of talking to other web services or databases, your costs could be higher than you might normally expect. So it's worth doing the due diligence to sort of delve deeper into that. So once you've done all this, and assuming you don't have any sort of business or technical issues that you can't overcome, you're going to come up with sort of your final list of components, and then you're going to move on to the final stage where you're going to plan and execute each migration. So for that, obviously, just like with any other project, what you're going to do is you're going to come up with a project plan with your effort and timeline required to do the migration. Now, if you're unfamiliar with sort of, where to get started with Windows Azure or how long something might take, one good resource is to look at some of the case studies that are on the windowsazure.com site. There's a lot of other companies here who have case studies about applications they've moved, the industries they're in, and all sorts of things like that. So, all that told will sort of help give you some guidelines on how long it might take to do a migration, what effort might be required, and even some architectural decisions that other companies have made. Another thing you want to take a look at when you're actually executing your migrations is, do you do sort of a big bang approach and try and move everything all at once, or do you take a more gradual approach? So an example of the latter would be if I've got sort of a website and a database, I might choose to move the database to the cloud, but I might leave the website on-prem in my data center. That might help me to actually sort of just concentrate on one set of issues at a time rather than trying to solve everything all at once. Another thing we often find useful too is, especially if you're unfamiliar with the Windows Azure environment, is to try proof of concepts or prototypes. So just create small little applications to test out various different concepts or things that your application needs to do. That can be a big help in trying to determine how I can most efficiently use the Windows Azure platform. So now that we've got this process done and we've come up with a short list of applications, what we want to do is we want to figure out exactly how we do this architecture mapping to the cloud. So first off, I want to talk about some just very high-level concepts in cloud computing. We've got three different main things that we want to talk about today. IaaS, or infrastructure as a service, PaaS, or platform as a service, and SaaS, or software as a service. IaaS, or infrastructure as a service, is where the cloud provider, in this case Windows Azure, provides the underlying hardware and virtualization software and the networking, but you're responsible for the applications, the data storage, as well as the operating systems and virtual machines that you want to run your applications off of. With PaaS, or platform as a service, the cloud provider takes care of not only the underlying infrastructure, but the virtual machines and things like that as well. So all you have to bring to the table is your applications and data. And finally, we have software as a service, where basically you're just bringing your users to the table. You're using somebody else's software. So an example of IaaS is obviously Amazon is big in that space. And with the new capabilities that Windows Azure has introduced this year, now Windows Azure has that capability to play in that area as well. With platform as a service, that was what Windows Azure originally was when it first came out. And that's a really good way of having a low maintenance way to run your applications in the cloud. And finally, software as a service, you've got examples like Salesforce.com or even Dynamics CRM Online. So another way of looking at this is if you take a look at all the individual layers here, you can see everything in orange is what a cloud vendor provides, like Windows Azure, and everything is blue is what you bring to the table. So if we look at the IaaS side on the left, obviously you're taking care of everything from your application all the way down to the OS that you want to run, and with Windows Azure that could be Windows or it could even be Linux now. And the orange stuff is what Windows Azure is taking care of, all the underlying hardware and virtualization software. As you move towards platform as a service, the cloud vendor takes on more of that responsibility for you. So now with PaaS, you don't have to worry about things like every Patch Tuesday when all these patches come out, is Microsoft will automatically patch your underlying VMs for you. With the IaaS approach on the left-hand side, you have to do all that maintenance yourself. Now let's talk about some of the components that are in Windows Azure, and then some of these things I will actually be doing as part of the demonstration that I've got in this presentation. To start off with, there's something called Windows Azure websites. This is a really good way of quickly spinning up, sort of a single web application, or if you want to run a WordPress or a Drupal site, that kind of thing. I'm not really going to talk too much about websites in this presentation because generally speaking, they're not really that suitable for migrating an existing application that you would have today. Next, we have something called cloud services. This is basically a platform as a service type component in Windows Azure, where basically you take your existing code, and it could be an ASP.NET application, it could be a PHP application, or it could even be a Java application running under Tomcat. You use the SDK to basically package it all up and create a deployment package that you copy up to Windows Azure. And then Azure handles actually creating a virtual machine for that, deploying your code into it, installing it into IIS if you're using that, running any startup scripts that you've defined, and then bringing up your applications for your users to use. Once again, Microsoft is responsible for keeping all the underlying infrastructure running, and they do the patching for you. But in some cases, especially with migration scenarios, you may need to resort to the new virtual machine capabilities. With this you can create virtual machines on-premise and then upload them to the cloud, of course after you sysprep them. Or you can use virtual machine templates that Microsoft already has in Windows Azure, and they've got not only Windows Server virtual machines, but even a variety of Linux variants as well. You can pretty much, just like any VM that you would run on-prem, you can go remote into it, install whatever software you need and things like that, but you are responsible for maintaining all that stuff yourself. Next, we have storage components. So there's a variety of different ways that you can store your data in your applications. Of course, a lot of your applications today may be using databases. So there is something in Windows Azure called Windows Azure SQL Databases. This used to be called SQL Azure. These are sort of a managed version of SQL Server 2008. So what it is it's basically got a very large subset of the SQL 2008 functionality. You can create your tables and store procedures in there and store all your data. Microsoft sort of manages those databases for you. There's 3 replicas of each database for high availability, and Microsoft worries about keeping them in sync for you. Alternatively, you can use something called Windows Azure Blob Storage. This is sort of a very highly scalable way of storing binary large objects. So these could be things like VHD files, they could be media files, they could be documents, whatever you basically want to store. And finally, on storage mechanisms, we have something called Windows Azure Tables. This is another way of storing sort of structured data with rows and columns. It's not a relational data store. You can kind of think of it almost like a NoSQL store. It's not quite that, but that's probably the easiest way to explain it. Once again, it's very highly scalable. You can store lots and lots of data. Finally, we have sort of the networking components. Windows Azure has something called virtual networks, which allows you to network your different virtual machines or cloud services running in the cloud together. You could even network to things that are on-premise if you've got a hardware-based VPN device, which is really good. We also have a queuing mechanism. So this is similar to what you would have with MSMQ or MQ series, where if you need to send messages between applications or application components, you can use the queuing mechanism. And finally, we have something called the service bus. This is another way of sort of having sort of more disconnected or asynchronous communications between components. It has a queuing mechanism of its own with some differences from the queuing mechanism I discussed before, or the ability to relay or broadcast messages from one component to another. The nice thing about the service bus is you can also use that with on-prem components as well as Azure-based components. If we take a look at, in a little more detail at some of the differences on both the compute and storage size to sort of help you figure out, well, which component is going to be suitable for my application, we can take a look at first at the compute side with cloud services and virtual machines. If you've got an application where it's a little bit less complex, maybe you've got sort of a web application and you've got some back-end services doing some back-end batch processing, you're not really integrating into other systems like Active Directory or SharePoint or anything like that. If you're mainly sort of more of a service or website-based application, a cloud service is a really good alternative for that. If, on the other hand, you're trying to install more of a server product like Active Directory or SharePoint or something like that, or you've got a more complex integration where you're integrating between different server products, the virtual machine approach might be a better case opportunity in that case. If you need to install external components, so things like frameworks, or if you've got a Java application, you want to install Tomcat and things like that. If it's something that can be installed relatively quickly within seconds or minutes, and it's something that you can automate through scripts that doesn't require any manual intervention, the cloud service is a good alternative for that. But if your setup is going to take a long time, or it's very complicated, or requires a lot of manual intervention, then you want to take a look at using the virtual machine. The other advantage of sort of cloud services that I mentioned before is that Microsoft will keep it up to date and patched for you. You don't have to do any of that. But if you use virtual machines, really the onus is on you to make everything kept patched and up to date. If your application is more sort of Windows or IIS based, definitely a cloud service is something that's good there. Obviously, if you're using a PHP application running under IIS, or you're installing Tomcat on a Windows box, you can still use cloud services. But for anything else, or if you need to run something off of a Linux OS, then a virtual machine is going to be the direction you want to go. Next, if we take a look at storage, I'm going to compare sort of using these Windows Azure SQL databases or SQL Azure to creating a virtual machine running your own version of SQL Server in it, or whatever other database product you might have, like MySQL. So with the SQL Azure databases, Microsoft manages that for you. I mentioned that there's sort of 3 replicas of the database there for high availability, and Microsoft manages sort of switching between the two, or if one goes down, bringing another one back to replace it. If you're using virtual machines, it's really up to you to come up with that sort of high availability infrastructure yourself. SQL Azure databases have most of what a typical application would need, so things like tables and columns, stored procedures and functions, triggers, indexes, all that kind of thing. But there are some things that are missing, so you don't have analysis services or integration services or database mirroring or log shipping. If you need any of that functionality, you're really going to look at creating a virtual machine and installing SQL Server yourself into that. SQL Azure databases also top out at 150 gigabytes per database. So if you need more data than that, then that might be another reason to go to virtual machines, where you can attach external disks up to a terabyte in size, and depending on the size of the VM and how many cores you're using, you can attach more and more virtual disks. With the SQL database, SQL Azure side, you can really only scale out and basically create more databases if you need to sort of service more data. One thing you can use to help partition your data out is there is a new feature called SQL Azure Federations, which helps doing the partitioning for you, or you can roll your own partitioning scheme if you need to. With the virtual machine side, you can do similar things, but you can also scale up. So because you're running this on a virtual machine, you can say, well, I want to use 1 core or 4 cores or even up to 16 cores with the appropriate sort of amount of gigabytes of memory as well. If you need Windows authentication, you really need to go the virtual machine route. The SQL Azure databases only support SQL Server authentication. And finally, you want to think about the costing. With SQL Azure databases, you're really just paying for the cost of the database. And sort of at the low end, I believe it's about $10 US a month for a 10 gigabyte database, and it goes up from there. With the virtual machines, not only are you paying for the storage for your databases, but you're also paying for the storage to hold the VM images, as well as the cost to actually run the VM images and sort of all the CPU cycles as well. So it can be more expensive going the virtual machine route for running a database server from there. Now, if we take a look at some typical architectures that you might have when you're sort of trying to figure out how to migrate an application to the cloud, you may start off with a very simple cloud-only architecture where everything's running in Windows Azure. So you might have one of these cloud services running an ASP.NET application, and maybe you've got a SQL database, but you're running this in the sort of the managed SQL Azure environment rather than installing your own VM. Alternatively, you might have something like maybe you need to put an Active Directory server into the cloud. So then you might look at actually provisioning a virtual machine and then running your applications in that. You can also move to sort of more of a complex, once again, cloud-only architecture where you've got multiple components all running in Windows Azure. So for instance, in here, once again, we might have sort of our ASP.NET application running on our SQL Azure database, but maybe we need to use Windows authentication. So we might set up a virtual machine running AD and have that connected to our cloud service through a virtual network. And then maybe, for some reason, we need to run a SQL Server Analysis Services box. We might create another virtual machine and have that pull data from our SQL Azure database. In a migration scenario, you may also look at having sort of a hybrid scenario where you've got some of the components running in Windows Azure and some running on-premise. So an example here might be you might have an ERP system running on-premise, and if you're running SAP or something like that, you're probably not going to move it to Windows Azure. But you might leave that on-prem. You might have a customer portal that you're going to run off of a virtual machine or a cloud service in the cloud, and then use a virtual network to connect the two. And as I mentioned, if you've got a hardware-based VPN device in your data center today, you can actually have Windows Azure configure a gateway that allows your cloud services and your virtual machines in Azure be able to talk to your on-premise systems through your VPN. So now that we've sort of talked about not only the process to pick applications and what components there are, we're actually going to move on to actually doing a bit of a demonstration on how you can move an application to the cloud. So once again, before you sort of do any sort of migration effort, you're going to want to do a bit of training on your own. Once again, you're probably going to want to download the Windows Azure SDK so that, especially if you're going to use cloud services, that you can figure out how to instrument your applications. You're also going to want to get the Windows Azure Platform Training Kit, so once again, you can find out more about all the different things in Azure are and how to use them. So for this application, for this demo, what I'm going to do is I'm going to first set up a virtual network. And what I'm going to do then is going to create a SQL Server 2012 virtual machine, and I'm going to install a very simple database with just a customer table and a couple of store procedures in there. And then I'm going to create two other virtual machines that we're going to be running Windows Server 2012, and they're going to host a very simple ASP.NET application with a single web page that's going to connect to my database directly through the virtual network, not over the internet or anything like that, and call my store procedures to both retrieve and save data. So let's move on to our demo here. And what you're looking at right now is the Windows Azure Management Portal. So this is a website where you can go to manage all the different components that you have. You can manage your websites, your virtual machines, your cloud services, your SQL Azure databases, your storage mechanisms, those blobs, tables, and queues that I talked about, your virtual networks, and your service bus connections. So the first thing I'm going to do is I'm going to set up an affinity group. And what an affinity group is basically a convenient way for you to ensure all the different things that you want to build are sort of geographically co-located. And then you can give a friendly name to your group as well. So what you do for that is I'm going to click on the networks in my management portal here, and then I'm going to click on affinity groups. And then I'm going to get a list of any affinity groups I have, and then I can choose to create a new one by going to the toolbar at the bottom of the screen. And so a very simple dialog, I can add the name of my affinity group. And then I can choose what data center I want that to go into. And here you can see there's 2 in the US, 2 in Asia, and then 2 in Europe that I can pick from. And I would typically pick, being in Toronto here, I would typically pick the East US data center. Now I'm going to cancel out of this because I've already created this for time's sake. So once you've done that, it will create the affinity group, and now we can use it for other different things. So the next thing I want to do is I want to create a virtual network to allow all my different components to talk to one another. So what I'm going to do here is I'm going to go to virtual networks, and this is where I'm actually going to create my network. But before I need to do that, I need to figure out what IP address ranges that I want to use for my virtual network, and part of that's going to depend on how many sort of instances or virtual machines or services that I want to run in the cloud. Now, Windows Azure Virtual Networks use something called CIDR notation, or classless interdomain routing notation. So it basically looks like an normal IP address, but there's a slash and a number after that. So that will help us create some subnets under that. So you can look around, you can sort of look on Bing for various different CIDR calculators. I'm just using one I found here. So what I can do here is I can put in my sort of base root address, and there's certain ones that Windows Azure supports. So I'm just going to use 192.168.0.0/16, and I'm going to want 2 subnets here. One is going to be used by my application server instances, and one is going to be used by my database server. So I'm just going to create my 2 subnets here, And I basically want to say that I want at least 4 IP addresses in each subnet, because if I want to spin up more instances of my app servers, let's say, I need to make sure I have enough addresses available within that subnet to accommodate that. So I'm just going to submit that, and then here this calculator has come back and tells me sort of what the base addresses are that I need for Windows Azure. So here I've got for my application subnet, I'm going to put in 192.168.0.0/29, and for my database subnet, I'm going to use 192.168.0.8/29. And you can see here, I actually have 6 IP addresses available in each sort of subnet. So I've got room to grow here. So I'm going to switch back to my Windows Azure Management Portal, and I'm on the Virtual Network section here, and I'm just going to go down to the toolbar at the bottom and hit Create. So what I can do is I can give a name to my virtual network, and I can pick my affinity group that I just created, and I can click Next on the wizard. So here is where I want to actually put in those subnet addresses that I created. So first I'm going to put my base major address in there, so 192.168.0.0/16, and don't forget to hit the plus sign behind that to make sure that it is added there in the portal. Now I'm going to create my app subnet, and I'm going to put my 192.168.0.0/29 and add that. And then I'm going to create my database subnet as well, 192.168.0.8/29. And there. So now I can just move to the next step of the wizard. And Windows Azure has its own DNS server, but if I wanted to use my own or a public one, I could actually put the address of the DNS server in here as well. If I wanted to connect to an on-prem network, I would check off this box, and then I would enter the address for a subnet for my gateway. And what I will do is later on there would be a further step to actually get the hardware-based IP, the address of my hardware-based VPN device that's on-prem, and then be able to connect the two through a gateway. In this case, I'm going to run everything in the cloud, so I'm just going to leave that blank. And then all you have to do is sort of click the check mark to complete the setup. Once again, I've already created this before, so I'm just going to cancel out of that. So now that we've got the virtual network, what we're going to do now is we're going to create a virtual machine for our SQL databases. So to do that, all you have to do is I can go to my virtual machine section of my portal, and I can click the new button down here at the bottom, and I can pick Compute Virtual Machines, and I can pick to choose a VM from a gallery that's already there of pre-created images that are supplied by Microsoft. So one of the images that I'm going to use here is a Microsoft SQL Server 2012 eval VM. You can see there's a lot of other VMs in here. I can just do a Windows Server 2008 or 2012. There's even a whole bunch of variants of Linux that I can use as well. So I can move on to the next step of the wizard. I can type in a name for my VM. It's going to create an administrator account so I can log in and remote into it, so I have to supply a password. And I can specify the size, basically how many cores do I want this VM to use. Now, if I go extra small, just because this is a demo, I could do that, but it will limit me in how many external drives I can attach. So I want to leave it as small for now, because I'm going to attach 2 external VHDs, one to give me 2 data drives, one for my database files and one for my log files. So I can then go next. This is going to be a standalone virtual machine, so I have to give it a unique DNS name. And then I can have to specify a storage account where we can actually put this VHD file. I can let one get created for me, or I can use one that I already have existing. And then I specify my virtual network as well. Go next. An availability set, I can choose to specify that. That's if you're running multiple copies of a VM. So for instance, we're going to use this availability set when we actually create our application servers, so that we can link them all together so that we can guarantee at least one is always running. And then I can also specify what subnet I want this virtual machine to go on, which is in this case the database subnet. Once I've done that, I can just click the check mark to create, and it'll go off and create my VM for me. That takes a few minutes, so what I'm going to do is I've already got some pre-created ones here that we'll use. So I mentioned that we want to attach 2 data disks to this VM as well. So to do that, what I have to do is select my VM. And what I can do is go down to the toolbar at the bottom of the screen and go to Attach, and then go say Attach Empty Disk. This will allow me to specify sort of the name of a VHD file that I want to create and how many gigabytes in size do I want. So I could create one here called data for my database files. And maybe I want that to be a 50 gig file. And then I can just click check, and then I can do the same thing for my log file disk as well. So now that I've done all that, what I want to do is I want to go into the VM and actually set it up. So you'll notice here, once you're looking at a VM in your management portal, you've got a connect button down here on the toolbar. So what I can do is I can click that, and that will actually give me a remote desktop connection into my VM. So I'm just going to open this, and this is exactly like you would be connecting to an on-prem server through RDP as well. So I'm going to sign in with the password that I gave when I created my VM. And I'm just going to sign in here. So now we're in a Windows Server 2008 image running our eval copy of SQL Server 2012. So the first thing you're going to want to do in this particular case is you're going to want to run disk management. Because I added 2 empty VHDs, they're completely unformatted when I do that. So what you're going to want to do here is go into disk management, and then these would, you'll notice here I've got an F and a G drive. Normally these would appear as sort of unformatted, unpartitioned. You can just right-click each partition and just set up your partitions in there and get them to format. You'll notice now I've got 2 10 gig NTFS disks that I'm going to use for my, database files. So if I actually look at those, you can see here in Windows Explorer, I've got my C and D drives, which are provisioned automatically when I created my VM. But now I've got my F and my G drives. So on my F drive, I created a data subfolder to hold my database files. And on my G drive, I have a logs folder to hold my log files. Okay, so let me just close those down. So the next thing I want to do is I want to go to the server manager. So we'll just get that to come up here. And one thing I'm going to want to do is, because this is a SQL Server box, I want to open up port 1433 so I can receive traffic for my database. So I'm going to go into Server Manager, go down to Windows Firewall with Advanced Security, click on the inbound rules, right-click and create a new rule. So what I'm going to do here is I want to select port. It's going to be on TCP port 1433. And then I'm going to accept all the defaults. I want to allow connections, across all different connections, and then I'm going to give it a name. I'm already sort of pre-done that, and I've got my sort of SQL Server role up here at the top. So now port 1433 is open for all the other traffic that's going to come from my application servers on my virtual network. The next thing I'm going to want to do is I'm going to want to go into SQL Server Configuration Manager. And I'm going to want to double check under the network configuration that all my protocols are running. So if anything wasn't enabled here, I would enable it. Go to my services, right click my SQL Server instance, and then just restart it to make sure my changes apply. After I've done that, what I want to go do is go into Management Studio and start setting up my application database. So we're just going to bring up SQL 2012 Management Studio here. And the first thing I'm going to want to do here is I'm going to want to make sure that SQL Server authentication is set up. So once this comes up, what we'll do is we'll sign in first with our admin account. I'm going to right-click on here, go to Properties on my server instance. I'm going to go to Security, and I'm just going to make sure SQL Server and Windows Authentication Mode are turned on. If it wasn't turned on, I would set that, and then I would just right-click my server to do a restart on that to make sure that applies. After I've done that, then I can go into my databases folder here. I can right-click and do a new database. I've already done that. So in this database, you can see I've got a very simple one. I've got a single customer table, and I've got a couple of stored procedures here that I'll use to both get and retrieve, update data in my table here. And so I can just do a quick query to make sure I've got some data. I've got some data preloaded in here. Oops. Just got to switch to the right database. Run that, and there we go. We have some sample data, and you'll see all this data appear when I actually run the application part of the demo. So now basically I've got everything set up. The one last thing I want to do before I exit here is I do want to show you the IP address that got configured here. So I'm just going to do an IP config. And maybe a bit hard to see, but my IP address here is 192.168.0.12, which falls in with the range of those IP addresses that I created when I created my virtual network. So this is something I'm going to use when I'm actually setting up my web applications. So now my SQL box is ready to go. I'm just going to close everything down and log out of here. So now that I've got my database server, what I want to do next is I want to create my application servers. But because I want two of them, what I'm going to do is I'm going to create an image first and then provision my two VMs off of that image. So what I can do is, once again, I'm going to go to New Compute Virtual Machine from Gallery. I'm going to pick Windows Server 2012 as my image, just because it's got .NET 4 and everything already installed. I can give it a virtual machine name. And give it a password. And in this case, I'm actually just going to use a extra small VM image because I don't need to, I'm not going to attach any other disks to this VM. I can give it a DNS name. I'm going to use the storage account that was created from my SQL VM images, so they're all in one place. And then I'm going to select my virtual network. Move on to the next step. Now, because I'm only creating an image here and I'm not actually creating the actual VMs that will host the code, I'm going to leave the availability set blank and I'm not going to put it on a subnet. So after I've done that, I can just click OK and then it will go off and create my VM. So once you've done that, if you go back to virtual machines in your dashboard, you will see sort of a VM representing that application server. So what I can do there is I can then connect to that one, and I'll actually start setting up my application code in my image, so I don't have to do that for each instance of my app server that I want to run. So once again, I'm going to select my app image. I'm going to go connect, and I'm going to get an RDP connection. So I'm going to sign in here. And as this comes up, you'll see this is Windows Server 2012, so it looks a lot like Windows 8. So we're going to let Server Manager start up here. It's going to take a sec while it collects stats. While it's doing that, I'm just going to show you that I've already pre-downloaded the source code for my application to the C drive here, and I've dropped it on my hard drive here. So you'll be able to see it's a straight Windows ASP.NET application, so very straightforward. It's a single page there. I'm going to just show you the web.config file. And you can see here I've already pre-changed the database connection string in the web.config file to use that 192.168.0.12 IP address of my SQL server that I've already set up. So it'll be able to talk to that. So the first thing I would do in this image when I'm setting it up is, of course, I'm going to go in here to add roles and features, and then I would actually set up IIS and ASP.NET so I can run a web server. So you can just step through the wizard here, and if I scroll down here, you'll notice I've already configured IIS to be installed, and if we drill through here, you can also see that ASP.NET has already been installed as well. So basically everything's there is ready to go. The other thing I've done here is if I take a look in IIS, I've already changed the default website to point to my application code that I've downloaded that I showed you on the hard drive there. So I'm just going to go to my default website running on port 80. If I take a look at the basic settings, you can see the path here is pointing to my application code that I showed you before. So after you've done all that, the final thing that you're going to want to do once you've got all your application code and all your components installed is you're going to want to sysprep this image. So just like you would do with an on-prem VM that you want to virtualize, it's going to go to Windows, System 32, sysprep, run the sysprep utility. You're going to want to set system out of box. You're going to want to check off generalize, and I want it to shut down once it's finally finished sysprepping this particular image. So I've already done that, so I'm going to just cancel out of that. I'm going to sign out of my VM here as if it had finished. And so what you do after you've done that is you'll see your virtual machine appear here, but it'll end up in a state of stopped. Or if it isn't, you'll just have to stop it yourself. Once you've done that, you'll notice there's a button in the toolbar down here called Capture. What that will allow you to do is once you've done that is it'll allow you to convert your VM into an image that will then show up in that image gallery when I create a new virtual machine. You do have to then specify if you've already sysprepped the image or not. So now if I go here to New, Compute Virtual Machine from Gallery, I can pick my images, and then I'll see here this is an image that I already created. It's a Windows Server 2012 image with my application code all installed. So I can basically step through the wizard like I did before, and now I can actually create 2 instances of this image that I'm going to use to host my application. So I'll have to specify a password once again. Like a type. And I'm just going to put this on an extra small. Move to the next step. Here the first image I'm going to create is going to be a standalone virtual machine, so I will give it a DNS name, and then I'm going to put it on my virtual network. And then I'm actually going to create an availability set for this. And then I would actually put this on my app subnet. Now, for the second VM, I'm going to go through those exact same steps, but I'm going to do something different when I get to the VM mode. There, what I'm going to do is I'm going to say I want to connect to an existing virtual machine. From there, it's going to let me pick all the other virtual machines that I currently have running. So if I created my first copy of my application server, I would then pick that one. Then when I step to the next set of the wizard, I can pick my existing availability set name, put it on the app subnet, and then I'm ready to go. So once I've done that, I'll end up with 2 copies of my application server running. They're both that plus the database server all on the same virtual network. So what I can now do is I can open up my browser, and I can go to the publicly facing IP address. Oh, sorry, one other thing you have to do before we do that is because these VMs actually need to expose an externally facing endpoint, in this case port 80, to accept web traffic, I do have to go into each one of these VMs, and I have to go to the endpoints section, and I have to create that endpoint. So I just go click Add Endpoint, and I can specify a name for it, like HTTPN, specify the protocol, the port I want it on, and then just click OK. And I would do the same thing for port 443 if I wanted to do HTTPS. You do that on the first VM image, then you're going to want to set to the second VM image, do the same thing, but when I go to the Add Endpoint wizard, I want to select Load Balance Traffic on an existing endpoint. That will allow me to have actually 2 application server VMs all behind the same publicly accessible endpoint, and Windows Azure handles load balancing between the 2 of them. So now if I open up a browser window and go to my website, I'm going to open 2 copies of it. And you should notice here at the top of my screen here, I actually have the IP address shown. So here I have 192.168.0.5. On my other page, I have 192.168.0.4. So you can see they're running on 2 different instances. I can actually type in a value here. And I click Save. Now it's actually saved it to my database server. If I go over to my other image and just do a refresh, you'll see down here at the bottom, it's got my Windows Halifax row that I just added on my other thing. So there, we've actually sort of migrated an existing ASP.NET application and a SQL Server database to the cloud. The only change I made to my application was the connection string in my web.config file to point to the IP address of my server. But I didn't do anything else in terms of the database code or the application or anything like that. Okay, so that's the demo. We're going to switch back to the presentation now. So next, what we want to finish off with here is we're going to talk about some of the challenges you may face when doing a migration and some of the things that you want to keep in mind when you're doing a migration of an existing application. So first off, if you're using a virtual machine, we showed how you're going to have to remember to open up any ports that you need in the Windows firewall inside your VMs, and you're also going to have to create an externally facing endpoint for your VMs as well if you need something external to Windows Azure to be able to access that. So in this case, we actually created an endpoint on port 80 for our HTTP traffic. If you're using the cloud service or the platform as a service approach to host out your applications, and some of this also applies to using virtual machines as well, there are some things that you need to keep in mind. The first off is everything running in Azure defaults to using UTC time and ENUS as the default culture. So this is really important if you're in SQL Server and you do a get date, or if you're in your .NET and you do a datetime.now, the time that you're going to get back is UTC time, not Eastern time or Pacific time or anything like that. Because it's so easy to scale things in Windows Azure 2, if you're running a web application, don't forget to account for out-of-process session state. So you may need to externalize your session state into something like SQL Server, or even Windows Azure has a component called the App Fabric Cache that you can use for that purpose as well. Because you're running all this stuff on remote hardware and it can be a little bit more difficult to access stuff, you definitely want to make sure that you set up a remote desktop connection into your VM so you can actually see them. If you're using the virtual machines and you're using those templates that Windows provides, it sets all that up for you. If you're creating a cloud service, you may actually have to set that stuff up yourself, but if you're using the Windows Azure SDK with Visual Studio, there's a lot of stuff to make that a lot easier. You're also going to want to make sure that you instrument your diagnostics as well. There is a way in the Windows Azure SDK to get your applications to dump their log files, your IIS logs, your event logs, or even your custom log files out to a Windows Azure table so that you can then consume it more easily without having to remote into all the different instances you might have running in the cloud. Finally, if you're using cloud services and you're using a third-party component, so maybe you're using components from Telerik or Infragistics or something like that, you want to, in your assembly references in your project, make sure you right-click them, go to Properties, and set the copy local property equals to true. This will allow, when you're packaging up your applications to deploy them to the cloud, is it make sure it includes those assemblies along because they won't exist in sort of the default virtual machines. If you're kind of wondering what's actually in the GAC on Windows Azure, you can go to this site, gacviewer.cloudapp.net. There they list all the assemblies that are in the GAC by default, and you can even upload your CSproj file and it'll tell you what components are missing that you have to mark with a copy local equals true. If you're using one of these Windows Azure SQL databases or SQL Azure, there are a few differences from connecting to a normal database. So the connection string format's slightly different. You'll notice the server name is prefaced by TCP:, and then it's servername.database.windows.net. The username is suffixed by an @ symbol in your server name. And you also want to set encrypt equals to true and trust certificate equals to false to make sure that all the traffic to your database is encrypted and to prevent any man-in-the-middle attacks. Windows Azure, the SQL databases also have their own firewall, and this is separate from the Windows firewalls that I showed during the demo. These can be managed directly through the Windows Azure Management Portal. You can set up firewall rules at both the server level and the individual database level, but you need to do that to make sure that anything trying to connect to that database will be allowed in. And there is even a checkbox if you've got stuff that is already in the same data center to make sure that it can connect. Another peculiarity for SQL Azure databases is that every table actually needs a clustered index. Otherwise, you will not be able to insert or update data in those tables. Part of that is to facilitate this sort of 3-replica high availability scheme that they have for SQL Azure databases. Some other things to keep in mind when you're using one of these SQL Azure databases is because you don't have the ability to scale up, unlike the ones that you might install into a virtual machine. Windows Azure will try and make sure that everyone has a consistent level of resource utilization. So if you're using too many resources, you might get a connection disconnect. The link there that's in the presentation gives you information off of MSDN about conditions under which you could be disconnected if you've got millions of transactions going through your CPU utilization spikes and things like that. To get around this type of thing with SQL Azure databases, they usually recommend implementing some sort of retry logic. The link that we've got there in the presentation basically links to something called the Transient Error Handling Framework, which basically helps you implement retries when you're connecting to databases and executing stored procedures and the like. The final thing I want to talk about with SQL Azure databases is there's really no support for backup and restore as like you have with an on-prem database. There is an import-export facility which will export an existing SQL Azure database to what's called a backpack file that includes both your data and your schema to a single file in Windows Azure Blob storage. So it can be a very good way to do that. The one thing to watch though is that export operation is not transactionally consistent. So because that export could take several minutes, if you've still got transactions coming in, they're not guaranteed to end up in that backpack file. So what we usually recommend there is that there is a SQL command you can execute called create database as copy of, which will create a transactionally consistent copy of your database so that when that copy is finished, you're guaranteed to also have any transactions that occurred during that copy, and then you could export that copy out and then delete the copy. One other thing to keep in mind really is cost. Because Windows Azure is based on consumption and developers oftentimes don't think about these things, especially when they're using on-premise hardware, you really need to think about how much this is going to cost you. So in terms of compute, anytime you have anything deployed to Windows Azure, it is costing you even if you have stopped it and it's not running. So oftentimes what we get is especially when people are trying to use the Windows Azure Training Kit, they'll deploy a bunch of sample apps to the cloud, forget they're there, and then they'll get a bill at the end of the month. So you really want to be careful about what your compute costs are. You also need to be considerate of bandwidth. Data coming into the data centers is actually free, but data coming out you actually have to pay for. So you really want to think about the amount of data that you're sending out, whether you're doing any sort of compression, how chatty your applications are, and things like that. And the final thing on cost is storage. Not only are you paying for the space that you consume, but you're also paying for the number of transactions you use to access your storage mechanisms. And those are specifically those Windows Azure blobs, queues, and tables I talked about. The cost is actually relatively cheap. It's like, I think, something like a penny for 1 million transactions, but they can add up if you're not being careful. So for instance, if you built a service that's pulling a queue every 200 milliseconds, those transactions can add up by the end of a year. So you really need to be careful about that kind of thing as well. So that's it for our presentation on how to migrate to Windows Azure. I think, Jonathan, we've talked today about some sort of a business process that you can follow to figure out what applications would be really good candidates for migrating to the cloud, as well as looking at from both a technical and a business perspective. So what are you going to get the most return on investment on? What are you going to be able to sell to your management? We also looked at what some of the components are in Windows Azure that you could use for a migration and when you might use one over another. We did the demo where we took a look at migrating an ASP.NET application and a SQL Server database to the cloud with very few changes at all. And then we sort of ended off by talking about some of the things that you want to keep in mind when you're doing these types of migrations.
Yeah, and I think that the important part, as you guys saw in the demo, was as you were going, you were building these networks, which effectively, for all intents and purposes, you would have done on premises as well. Mm-hmm. Probably not as easily because you don't have the wizards that kind of walk you through. But once all of that configuration in the portal was done, the deployment of the application is relatively simple, right? You said what? It was just the web config change and you're good to go. Right? Which, if you think about it from a migration perspective, actually makes things very easy to get yourself in the cloud and then worry about, as you're there, you kind of tweak and then maybe take out writing to whatever storage and you put in Azure storage. Or, if you wanted to one day move away maybe from a SQL Server database in the virtual machine, you can move it to a Windows Azure SQL database. All the different things like that, right? So you're kind of, and correct me if I'm wrong, but I think that the best approach here, as you've kind of gone through, is move it the one step, see what the world looks like in the cloud, and then see where you go from there. And potentially, you might actually just leave it there. Yeah,
definitely. And I think, especially if you're unfamiliar with the platform, there are little things that come up here and there. Things work slightly differently. Configuration might be slightly different than you're used to. So that sort of graduated approach really does help, I think, to let you focus on one set of issues at a time rather than trying to solve the world's problems. So.
Perfect. All right, well, that's it actually for this session. Make sure that you get those questions into the chat so we can actually answer them while we're on break or at the end of the day as well. In the meantime, we're going to take a short break while we set up here for the next session, and we'll see you in a bit.